Hello everyone, my name is Akib Hasan and I'm going to present about the unique biodiversity of esker lakes, and this project has been supervised by Professor Miguel, Professor Guillaume and Professor Imbeau. First, I want you to imagine our world like this. I know it hurt because we are experiencing global warming, so, but it was a situation of our world during the last ice age, which happened about 10,000 years ago. During that time, 97% of Canada was covered in thick layer of ice. The thickness of ice was up to 2 kilometers in several places. During that time, a complex geological formation was created that now we call esker. Eskers are made of layers of sand and gravel. Now these eskers are distributed over all northern countries, including Canada. Here you can see all the eskers from Canada with the red in the left side. And here the St. Matthew Lake Berry esker from MRC Abitibi. The lakes on eskers are usually connected with groundwater system and they are not connected with other river system. And this type of system creates them as a closed basin wetland. And this system actually affects the water temperature, water quality, and water nutrient. Eskers also provide several services. For example, esker provides sand and gravel, which is used for constructional purposes. Eskers also provide one of the best quality drinking water in the world. Eskers also provide fungi, so mycotourism is very popular in esker lakes. Eskers also provide archaeological sites. For example, eskers provide the archaeological identity of this region. Eskers also provide the opportunities to leisure time activities, recreational activities. And eskers also provide productive jack pine timber. Due to these services, eskers face several threats. For example, over-exploitation of sand and gravel actually alter the natural bedrock of eskers. Also, over-harvesting also has a negative impact over the biodiversity, and several other anthropogenic impacts such as camping or introduction of species can also have a negative impact over the biodiversity. And there is a huge knowledge gap about the biodiversity and functioning of esker ecosystem. And to reduce this knowledge gap, we're implementing a unique food web approach. Waterbirds act as a top predator in esker lakes, but their population depends on the macro-invertebrate community, which is the feeding resources for them, and also fish community, which determines the macro-invertebrate community and other resources in the lake. Therefore, the objective of our study is to evaluate the waterbird biodiversity associated to esker lakes and also identify its environmental drivers. Our first specific objective is to assess the aquatic resources such as type of habitat, quality and quantity of macrophyte, macro-invertebrate, and fish communities. Our second specific objective is to assess the richness, evenness, and diversity of waterbird, and also record the occurrence of indicator species such as common goldeneye and Bonaparte's gull. Here's our conceptual framework. You can clearly see these two types of lakes are very different than each other. In esker lakes, they usually have low water temperature because they get the water reaches from the groundwater. Therefore, they have high dissolved oxygen. There is also no or less number of fish because they are not connected with other river system, and they also get more light because the water is very transparent. Therefore, they usually have more aquatic macrophyte and algal communities. So all these factors positively affect the aquatic invertebrate, which should be higher in esker lakes. Therefore, we are expecting in esker lakes there should be abundant, rich, and diverse waterbird community. On the other hand, in clay lakes, there is less light because the water are not clear, and so therefore they should have less algal communities and aquatic macrophyte, and there is many fish, and the water temperature is high in clay lakes. Therefore, there should be low dissolved oxygen, and all those factors negatively affect the aquatic invertebrate, which should be low in clay lakes. Therefore, we are expecting in clay lakes there should be less abundant and less diverse waterbird community. Therefore, our first hypothesis is that the abundance and diversity of macro-invertebrate will be higher in Kettle Lake of eskers compared to the lakes on clay because of their available resources and reduced precipitation. Our second hypothesis is that the richness and diversity of waterbird will be higher in esker lakes compared to the lakes on clay because of the available resources such as macro-invertebrate. Here I'll discuss the method. So at the beginning, we had 80 lakes around this territory, and depending on the size of the lake, location of the lake, and logistic, we selected 50 lakes. There is the 50 lakes around this territory, and among these 50 lakes, 25 situated on eskers and 25 situated on the clay belt. To survey waterbird, we use point count and flash count method. Two observers went to position of the lake and they count the bird for 20 minutes. Then they walked across the lake to maximize the detection probability. And there were 2 visits per lake. To survey fish, we set 3 traps in each lake and we kept the trap for 24 hours. Then we identified each fish species and then we measure total length, fork length, body weight, and species abundance. For macro-invertebrate, we collected 150 samples from 50 lakes with a D-frame net, and then we preserved the sample in ethanol, and then we sorted each sample in the laboratory, and we identified each macro-invertebrate species up to the family level. Now I'm going to discuss the result. Here's the waterbird biodiversity. Mean biodiversity index value is slightly lower in esker lakes compared to the lakes on clay. Mean abundance, total distance was also low in esker lake. For fish diversity, there is a significant difference. In esker lakes, the mean diversity index value is low compared to the lakes on clay. However, total distance was higher in esker lake. For macro-invertebrate, there is not significant difference, and in esker lakes, the mean diversity index value is slightly lower. For physiochemical variables such as nutrient and dissolved carbon, the concentration was lower in esker lakes compared to the lakes on clay. However, dissolved oxygen percentage was higher in esker lake. For salinity, conductivity, macrophyte cover, the percentage was lower in esker lake. For indicatory species in esker lake, we found the strong association of common goldeneye and Canada goose with esker lake. And in clay lakes, we found the strong association of ringneck duck and hooded merganser with clay lakes. In esker lake, almost half of the esker lakes was completely fishless. Therefore, we found only one indicatory species here. We found the strong association of yellow perch with esker lake. And for clay lake, we found the strong association of northern red-bellied dace, northern fine-scaled dace, and fat-head minnow with clay lakes. For indicator macro-invertebrate, we found the Perlidae family and order strong association with esker lakes. And for clay lake, we found the Coleoptera order and giant waterbug strong association with this type of lake. For our modeling, we found that there is a significant positive effect of total phosphorus and dissolved organic carbon over the waterbird richness, and we found a significant negative effect of lake area and harvesting distance over the waterbird richness. Now I am going to discuss this result. So we found the total phosphorus and total nitrogen dissolved organic carbon was lower in esker lakes, and this can be explained by the fact that esker lake are not connected with the river system, and they have a isolated, and that's why they get less nutrient input. Also, higher dissolved oxygen in esker lakes can be explained by the fact that esker lakes usually get their water resources from the groundwater, therefore they have low water temperature. Also, macrophyte cover percentage was lower in esker lakes because esker lake usually have low nutrient content. We found the diversity of waterbird is lower in esker lakes. However, few species showed strong association. For example, common goldeneye. Common goldeneye prefer fishless esker lake, because, especially during their breeding season, because during their breeding season they need to feed the duckling, and fishless esker lakes has lower competition with fish, no competition with fish actually. So that's why they prefer fishless esker lake. For fish, almost half of the esker lake was completely fishless, and isolation of esker lake and their lower nutrient content can explain this phenomenon. For macro-invertebrate, we found the Pallidae family, strong association with esker lake, like stoneflies, because they need more dissolved oxygen in the water to survive. And also the strong association of dragonfly and Thames flies in esker lakes can be explained by the fact that they act as a predator in esker lake. So to conclude, we can say that the diversity of the biodiversity in esker lakes is low in all trophic level in the food web. However, few and important communities showed some strong association with this ecosystem. But anthropogenic activity might alter this pristine ecosystem. Thank you everyone for listening.